This is Lucy. Getting Lucy the right medicine at the right time means less time seeing the doctor and more time playing the doctor. Andre just got his loan approved. He applied for it seconds ago. Rhonda's running late, but knows to the minute when her family meal will be delivered. These innovations come from you, the unsung hero. Apache Kafka, your superpower. With it, and the data-driven systems you create, you keep people alive. You help people thrive. You make people smile. But it's more than that. Your innovations enable other innovations, bringing new medical treatments to clinical trial, identifying and blocking cyber threats, preventing banking fraud. All of this in real time. That is what you do. That is why you are here. So, take a bow. You are Team Kafka, making the world better. For Lucy, for everybody.
Please welcome back Danica Fine and Kris Jenkins.
Hello, welcome back. I don't know about you, but I love seeing that video, okay? It is both adorable and inspiring, all right? I hope everyone agrees.
Yeah.
And if it inspired you as well, know that there are so many ways for you to also get involved in contributing back to the open source project so that you too can be a rock star for your community.
Yeah. Speaking of rock stars, I'm hoping you're all planning to join us for the after party tonight when we will be totally rocking out to one of Austin's best bands, Spoon. I hadn't heard of Spoon before this conference was announced, so I put their latest album on a loop, and they do rock, so I'm hugely looking forward to that. Please do come along. There are two things you need to know. It is a 10-minute walk from here in Austin city limits. There will be people to guide you all the way. Bring your conference pass. That is your ticket to get in to see one of Austin's top-rated bands.
Oh, great segue, Kris. Speaking of top-rated things, we've all downloaded the conference app, right? I need a verbal yes.
Yeah.
Okay, yes. Great, wonderful. Using that app, if you haven't done so already, you can build up your personalized schedule.
Thank you.
And also go in and give feedback to all those speakers. Remember, the speakers live on that feedback. We love it. And it is also great to see, who your favorite speakers were.
Yeah, and speaking of favorite speakers, I think it's time we welcome to the stage one of my favorite speakers and favorite minds in our community. Ladies and gentlemen, he's one of the original co-creators of Apache Kafka. He is one of the co-founders of Confluent. He's always replicating, but he's never been replicated. Please welcome to the stage, Mr. Jun Rao.
Well, good afternoon, everyone. So before I start, I want to just do a quick show of hands. How many people here are attending Kafka Summit or Current for the very first time? Wow, that's like a good 80% or 90%. Well, welcome to all the new and the returning attendees to this conference. So as Jay mentioned in the morning, Current is designed as the next generation of a Kafka Summit. The goal is to have this venue for this broader data streaming ecosystem based on Apache Kafka. But Kafka remains the foundation of this whole ecosystem. And in this talk, I'm going to focus on Apache Kafka. So what I'm going to do is to talk a little about how Kafka was created, how it has been evolving, and what are some of the new exciting innovations that's happening in this space. So if you are new to Kafka, this is actually one of the most popular open source Apache projects out there. It's used widely by hundreds of thousands of organizations across the globe, across the industry, including most of the largest Fortune 500 companies out there. And if you look at the statistics, how Kafka is being used in production, the numbers are pretty impressive. So how did that get started? Well, some of you may have heard that Apache Kafka was originally started at LinkedIn. Around that time, LinkedIn was seeing a tremendous growth in terms of the amount and the number of places where this digitized information is being generated. in addition to this traditional transactional type of data, there's 1,000x growth in other type of digitized information, including user behavior data, operational metric, application logs. Another thing LinkedIn was seeing is a tremendous growth in the number of places where this information needs to be leveraged. Some of those places are various data services LinkedIn has adopted over time, such as the next generation data warehouse, data lakes, search engine, and other things. But there are far more number of those places are data-driven applications LinkedIn can be building, and there were hundreds of those. So the key realization LinkedIn had around that time is just storing and recording those digitized information itself doesn't really generate value for LinkedIn. It's only when those digitized information is being leveraged in those downstream data services and applications, that's when it's actually generating value. So the sooner this data can flow into those data services and applications, the faster LinkedIn can leverage those data to derive new insights and then create business value. But surprisingly, around that time, when LinkedIn looked around the infrastructure that it can use around that time, there wasn't really a good infrastructure for satisfying what really LinkedIn wants. Around that time, databases were mostly designed as a data REST system, and a lot of traditional messaging systems, they just don't scale to that 1,000x need for this increasing amount of digitized information. Because of that, LinkedIn's data architecture over time became something like this. As you can see, there are lots of those point-to-point connections, and it's pretty messy, right? So we quickly realized that this is not going to be a long-lasting, sustaining solution. So that's why we created Kafka to solve this problem better. With Kafka, we created a brand new data streaming platform. In the first version of Kafka, we did two things. The first thing we did is to have this concept we call log as a first-class citizen in this platform so that it can deliver those data streams in real time more efficiently. The second thing we did is to make this platform really scalable. So even in the first version of Kafka, this is designed as a distributed system so that it can accommodate for that 1,000 times more amount of digitized information. With Kafka, we completely eliminated those point-to-point connection that we have seen earlier. All the data at LinkedIn are now being collected in real time in Kafka. And all those information is available as subscription to those downstream systems, whether it's data services or applications. Now, as soon as they subscribe to those data, the data can flow to them in real time. So what we created, essentially, is an opportunity for every developer at LinkedIn to take action on what's happening at LinkedIn so that it can generate business value. Seeing the success of Kafka at LinkedIn, this technology got quickly adopted to other technology companies. Fast forward to today, what we are seeing is this data streaming platform is now becoming mainstream. It's a technology not just needed by technology companies like LinkedIn, but it's a technology that's needed by pretty much every company in the world. Because every company is seeing the same need that LinkedIn had, because there's a growing amount of digitized information being generated pretty much in every company. And every company is having more and more of those places where data need to flow into. The abundance of fully managed service in the cloud makes the adoption much easier for those companies, creating more of those data sources and the data destinations. So with Kafka in those companies, just like LinkedIn, we are providing an opportunity for every developer in every company to act on what's happening in their business and generating business values and opportunities. As companies are adopting Kafka more and more, what we are seeing is this data streaming platform is becoming the de facto standard for this new category of data in motion. Now, let's hear the story how Kafka has helped one particular business to transform its business. Please join me in welcome CIO of United States Postal Service, Pritha Mehra on stage. Pritha.
Hi,
Pritha.
Jun.
Yeah, first of all, welcome to current 2022. Pritha, it's a pleasure to have you here.
Oh, it's a pleasure to be here. I'm learning something with every presentation.
That's great.
I'm losing this exabyte race, so I have to keep running.
That's great. So to get us started, everybody probably knows USPS, but not everyone is familiar with the internals, right? The scale, the scope at USPS. Could you share a little bit detail with us on that, and also, of course, your role at USPS?
Of course. So you all know we deliver mail, right? But we deliver tons of it, right? So it's 129 billion mail pieces across 163 million addresses daily, right? So that's a lot, using over 232,000 vehicles. So all of this has to be captured in digital, right? We have over 650,000 employees. We have lots of mail processing facilities. We have over 30,000 delivery units and post offices, and we get more than 10 million visitors to our website every day. As a CIO, I kind of guide the strategy, the technology strategy for the Postal Service. My team does the network, the data, the telecom, the cybersecurity, and most of all, the 900 applications that we have, a lot of which are legacy, but some of them are on the trajectory to modernize, and that's where Kafka comes in. We started our Kafka journey in 2016, I believe it was, yeah. And so we've got, we've got our own data centers. We've got, 115 petabytes of data, but that seems to be chump change around here. And we, run 28,000 virtual and physical servers. And so, yeah, we're big.
Yeah, that's still pretty impressive numbers. So I understand that during the pandemic, right, Postal Service played this important role in terms of delivering those COVID testing kits to all the American people. Could you share with a little bit of detail on that?
How many of you ordered test kits? Come on, raise your hands. Say thank you.
Thank you.
All right, so yeah, so this is a fascinating story. Actually, it was around December, Christmas Day, or somewhere roundabouts there, where the White House called our Postmaster General, Louis DeJoy, and said, can you deliver 500 million test kits across the country? And Louis is not one to say no, and so he said, but of course. And he is a logistics genius, so he set up these 6 transfer centers where we received the test kits from HHS, and then he had them delivered across 49 fulfillment centers where we stuffed the envelopes with 4 test kits, labeled them, and distributed them in 1.2 days. So that was fascinating, and we had to do that in 3 weeks. So, of course, Louis galvanized his entire team, and we were, of course, part of the team. So the CIO group was responsible for all systems, right? So it was our inventory systems, our tracking systems, our ordering systems, you name it. And of course, the most heart-wrenching part of this was that we had to stand up a website, and we were told that we should plan to handle 1 million test orders an hour. And my team and I got together and we said, wait a minute, COVID is rampant, there is a dearth of test kits, and this is free. It's going to be way more than 1 million an hour. So we planned for 20 million. And our design was very simple. It's up here on the screen, where we pretty much just had a synchronous portion and an async portion. The synchronous portion was accepting the order, validating the address, making sure the dude hadn't ordered one before, and then we put it on a Kafka topic, right? So the order was placed on the Kafka topic, and we had 3 consumers. that then processed the downstream applications, right? Sent it off to our inventory systems. And lo and behold, we did this in 3 weeks. I think it was tremendous. At peak, we got 8.7 million orders an hour. And on the first day, we handled 44 million. So that was pretty tremendous.
That's... Yeah, that's definitely a great story.
That's a pretty weak clap for such a Herculean effort, but I'll take it.
Yeah, but we definitely appreciate the effort. I remember that I ordered my test kits right online, and then it worked as expected, and then the test kits were delivered to my house, within just a couple of days.
Yeah, yep.
And then it's great to see Kafka playing like a pretty important role in this effort.
Was. We couldn't have done it without, really, because we had to process orders at a speed that was unprecedented.
That's great.
Yeah.
So where else have you guys been using Kafka for?
Yeah, so if you think about the Postal Service, we need a digital representation of all our assets. So it's the carrier movement, it's the vehicle movement, it's the trucks, it's the package scans, it's the mail, every scan of the mail piece. So all of this is ingested, and it's about 30 terabytes of data that we ingest into an application called Informed Visibility. And essentially, it's a digital representation of everything that's important for us. And we kind of, it's a mesh of about 400 Kafka topics that we have. And we power about 20 business applications. And, that the topics are, from raw data to enriched data to aggregate data, where we get to see, we visualize the delivery conditions of our post offices, our conditions of our processing units, our conditions of every package as it's getting delivered. We make sure that the carrier has delivered every package that they were supposed to deliver. So it's really a vast amount of data in motion that we are constantly gathering and using analytics to really drive operational precision, service precision. So
yeah, that's great. It is.
So that's one example. And then we are also geo-replication, right? So we are a multi-cloud environment. It's hybrid. And there are times when we need to create caches of critical enterprise data sets in different regions for performance. And keeping it in sync is where we use Kafka. It's a great platform to help us keep distributed caches in sync. But most of all, my dream is to have the Kafka registry, because if you think about just our package scan data, it's used across our organization. It's not just used for operational precision, it's used for fraud analytics, it's used for revenue, it's used for product, it's used for finance. So our goal now is to really create that Kafka registry with enterprise topics. And so we can have all of this cataloged, and our developers can just have a fun day making applications and not worrying about the data. So we are on that journey to really bring some structure around our data streaming.
Yeah, that's a great story to see so many places where Kafka can be utilized. So what do you see as like the future, especially on the digital side at the USPS?
Well, it's a great time to be working for the Postal Service. We have a real visionary of a Postmaster General. He's leading the implementation of a 10-year Delivering for America plan. And it's essentially modernizing everything. Logistics, delivery, processing, unit product, you name it. So the COVID test kit was just one example, and we are sort of using that solution to really offer a much broader scale of services for our organization. So I'm really having a blast right now because its technology is great. And we just deployed a new product suite. It's called USPS Connect. And it actually started here in Texas, where shippers can bring their packages either to a local post office or a regional facility, and they can reach their customers in 1 to 2 days. So you guys got to start thinking about us more, because we are truly one of those deliverers that shine. And event streaming is really at the core of our vision, of our data, of our new modernization strategies. And I do want to thank, because there are a lot of partners here in the room that help the Postal Service. So thank you for that, and thank you, Jun, for having me here.
Yeah. With that, yeah, thank you, Pritha. Yeah, wish you continued success with Kafka at Post Office. Enjoy the rest of the conference. Yeah, that's a great story. I'm sure everyone in the community probably shares the same feeling I had to see how this technology based on Kafka is doing this mission-critical role, right, in this important effort. So a big part of the success of Kafka really lies in its continued innovation. So over the years, we have had more than 560 Kafka improvement proposals being implemented, which capture some of the key innovations in Kafka. And together, there were more than 9,100 JIRAs of those issues being fixed. And we have had a total of 55 releases, 22 of them are major. And in the last few years, we have been releasing at a speed of 3 major releases every year. So we're innovating at a really fast speed. Let's review some of the past key innovations in Kafka that helped the growth of Kafka. After the first version of Kafka, we quickly released the replication feature, which increased both the high availability and availability, which made Kafka really possible to be used to implement the mission-critical applications. We also released the security feature. This allowed our customers and users to do the authentication and authorization using industry standard way. To solve the data integration problem, we also introduced the Connect framework. This allows people to build these connectors for the popular data sources and the data sinks so that it can integrate it with Kafka. We also helped making the stream application building easier. So we introduced a library called Kafka Stream, which allowed people to build those event-driven applications using some high-level construct. And we also added support so that each of those events can be processed once and only once with this framework. We also made various performance improvements. In addition to the improvements on the data plane, we have improved the scalability of a metadata layer, which is those number of topic partitions, by a factor of 10. We are not only just creating those innovations, we are also hardening those innovations, because we know our users are trusting this platform to build those mission-critical applications like delivering COVID test kits, as we have heard earlier. So as we innovate, we want to continue to maintain this platform to be rock solid. So every time before we have a new feature released, we invest heavily in things like code review, unit test, integration test, and system test. At Confluent, we also run some additional soak tests in the cloud infrastructure. After a feature is released, we pay really careful attention to feedback from operational experience from our users, and then we incorporate those feedback to continue to harden this platform. It's both the creation and hardening of those innovations that really helped the growth and the success of this platform. As Kafka evolved, over time, we have also created a set of open interfaces and protocols around Kafka. As we continue to innovate, we want to continue to make those interfaces and protocols open and backward compatible. It's those open, compatible interfaces and protocols that allowed further innovation in the whole ecosystem. Over time, we have more than 200 connectors built based on the Connect framework that allowed all those popular data sources and data sinks to be integrated with Kafka. We have implemented binding of the client languages for pretty much all the popular programming languages. So now if you want to do event streaming in your application, you have a choice to use your most favorite programming language. We have also made advancement in the stream processing space. Right now, there's abundance of the stream processing engines that people can use to make the job of building streaming applications and pipelines much easier than before. We owe a lot of thanks to all the people who created those innovations. So over time, just in the core part of Kafka, more than 2,200 people over time have directly contributed to Apache Kafka, and more than 1,500 people have reviewed those changes. So I want to have a big thank you to all those contributors and reviewers. We also owe a lot of thanks to our users. Our users not only help us validate those innovations that we created, but they also give us feedback to guide us on where the next wave of innovation should happen. Now, let's hear the story of how the past innovations in Kafka has helped another company to transform and innovate in their own business. Please welcome to the stage Chunyan Wang from Pintrest. Chunyan. Yeah, I have known Chunyan personally for a while because Pintrest has been a long-time Kafka user. So first of all, welcome to Current 2022, Chunyan. Hopefully you enjoyed the conference so far.
Yeah, thanks for inviting me. It's a great pleasure to be here.
Yeah, just to get us started, right? Perhaps you can tell us a little bit Pintrest as a business and your role there.
Sure, of course. So Pintrest, we are a visual discovery engine with a mission to bring everyone inspirations and create the life they love. There are currently more than 400 million monthly active users around the globe using Pintrest to either discover recipes, fashion style, and other ideas to try. A little bit about myself. I've been working at Pintrest over the past 10 years. I'm currently leading our big data infra and analytics platform organization.
Oh, that's good. Yeah, I know Pintrest has been a long-time Kafka user, right? So could you share us with a little bit the history of how Pintrest has been using Kafka?
Yeah, it's a long story. So we started to use Kafka back in 2012. At the time, we had a very similar need, like what you just mentioned in the talk, for a unified and high-throughput log transportation platform. Kafka became open-sourced. We evaluated and have been using it ever since. Right now, it's powering hundreds of different batch and stream use cases across Pintrest. For example, there are use cases like all the signals we generate for deep learning, visual search, as well as analytical use cases we have, such as real-time A/B experimentation, observability. All of those have been enabled through Kafka.
Yeah, that's good to know. So what kind of business advantages does Kafka provide for Pintrest?
Mm-hmm. I think, from my perspective, one key advantage is the capability to generate faster signals and recommend our users with real-time content. If you think about Pinterest compared to other social media platforms, I think one unique differentiator is that our users, they come to Pinterest with a strong purpose or intent to get inspired. Part of our strategy is to help our users turn those inspiration into things that are actually actionable in their lives, like a product they could shop, a recipe they could follow. And so we found real-time content recommendation is really crucial in helping us fulfill a closest loop from getting inspired, turning into action. As a user is engaging through our platform, in real time, all of those signals will flow through Kafka, translate into other relevant products or ideas recommended to the user in sub-seconds. And so this capability is really a key advantage Kafka enabled us.
Yeah, I think what you said is really well. I think being able to have this opportunity for every developer and user, right, to take actions on what's happening in the world, right, in real time. That probably will resonate with a lot of people in this audience. Could you share with a little bit like the overall data architecture at Pintrest with Kafka involved?
Yeah. So very high level, obviously, we use Kafka as the foundation for all data transportation, either if it's the activity log or if it's production CDC. And so once the data is in Kafka, we have the batch and the stream processing. For batch processing, we first move data to AWS S3, and we have a large in-house deployment of Spark for batch. For streaming, our team, we also run a Flink cluster to enable all of the streaming use cases.
Okay, that's good. So could you share with us a little bit the scale you guys have been running at?
We do have a large volume of data. And so we've been trying our best to clean up for both efficiency as well as compliance reasons. But still, we are getting very close to 1 exabyte on AWS S3. And there are 4 trillion new messages coming in daily as well, which translates to around 80 gigabyte data in and out of Kafka per second. So we're supporting this scale by running 50 Kafka clusters with thousands of brokers, around 500,000 partitions. I think our experience is one of the testament that Kafka can scale well, both vertically as well as horizontally.
Yeah, that's good to know. I think probably a lot of people in the audience will have in their mind, how did you guys successfully operate at such a large scale, right? Could you share with some of the challenges and the learnings you guys have there?
I think, first of all, from my own perspective, Kafka itself has been very stable for us, especially in the past few years, which I think largely thanks to all of the performance improvements, patches, keeps you and this community have been all making.
Thank you.
And so a lot of the challenges we have been facing are more related to scale. For example, things like instance hardware failure, traffic pattern change. And I think there are primarily 2 takeaways. One is that we used to be running Kafka on top of the magnetic disks instances on AWS. We found it particularly helpful to move away to use the NVMe SSD, the i3 or i4s, which gives us much more IOPS to work with in a high partition density environment. And that gives us just so much more performance improvements as well as stability boost. The second major takeaway is that we choose to invest heavily around automation. We have a project called Orion that is open sourced, which is formerly known as Dr. Kafka. It helps us take away majority of the manual operational burdens for things like automated broker replacement, automated cluster rolling upgrade, restart, workload rebalancing, and so on. So, yeah.
That's good. Yeah, it sounds like you guys have been building a lot of tools, right, around operational Kafka. Could you talk a little bit more about the tools you guys have been building at Pintrest?
We actually built several tools, and we try to open source them as well to contribute back to the community. And so besides Orion, the cluster automation engine I just mentioned, there are 2 projects called Singer and Seeker. I'm not sure how many of you have used it before, but so Singer is a high throughput logging agent that helps us to move data from local disk to Kafka. And Seeker is a Kafka consumer that helps us to persist the data from Kafka to S3 with strong consistency. Finally, another project we just recently open sourced, but is gaining a lot of momentum, is a project called QueryBook. It is essentially Pinterest's big data IDE with a notebook-style interface. We currently support a whole bunch of query engines like Druid, Presto, Spark SQL, Flink SQL. We may add the KSQL support there as well very soon.
That's great. Yeah, I'm sure those tools will help the whole ecosystem build around this data streaming platform. So one last question before you go. What's next? What's for the future usage of Kafka at Pinterest?
Yeah, that's a great question. For us, it's particularly, we are focusing on the concept of data mesh. In particular, as our organization gets bigger, we are facing the problem around the data discoverability and the data proliferation. And so we are investing in making our internal data as a product by building the data catalog, data documentation, table tiering to improve our analytical productivity across both batch and the streaming world. Our folks actually have a relevant talk on this in the morning session.
Great. With that, yeah, thanks, Chunyan. I think thanks for sharing your experience with us.
Appreciate it.
Looking forward to seeing more progress you guys have at Pinterest.
Thank you.
Enjoy the rest of the day. Well, so far we have heard how our past innovation in Kafka has helped companies like Pintrest innovate their business. So what's next? What's the next wave of innovation in Kafka? Well, in the past few years, I think a big wave of innovation in Kafka has been in the cloud. So when we first started Kafka, right, our users have no choice but to self-manage their own Kafka cluster. So if you ever have managed like distributed system like Kafka, you will know managing a distributed system is not easy, right? Because you have to worry about the operational part in a distributed way of the configuration, the monitoring, the logging. You have to balance the cluster. You have to worry about upgrade. To do this well, you really need to hire a team of experts. But today, things have changed greatly. Our users and developers have a lot more choices with the innovation in the cloud. Now, managed Kafka in the cloud are available, right? At Confluent, for example, we are offering managed Kafka service in the cloud called Confluent Cloud that's available in all the 3 major public clouds. So those managed services in the cloud significantly alleviate the operational burden of our user so that they can focus their effort on their core business value. Those managed Kafka services not only make the adoption of this technology much easier, but in a lot of cases, it all translates into lower cost, which is getting more and more important for the current uncertain situation. But offering Kafka in the cloud is really just the very first step. There are a lot of further opportunities to innovate in this space to provide a better managed service. Cloud behaves a little bit different from on-prem. In on-prem, you have to pay upfront, right, for all the hardware costs. But in the cloud, you typically pay for what you use. So by judiciously rethink about how you can use those cloud resources for Kafka, right, you can provide a much better overall service. So here I'm just quickly share like one such innovation we have done within Confluent Cloud. If you're familiar with Kafka, you know this is how Kafka stores data today. Each broker has its local attached storage, and all the data at Kafka are now distributed evenly, right, among those local storage in all those brokers. Now, what's the issue with this architecture in the cloud? Well, the first issue is potential cost, right? To provide that low latency, real-time experience in the cloud, that typically means we need to use this fast type of storage, right? But as our users start to retaining data in Kafka longer and longer for doing things like building system record, the overall storage cost in the cloud could be dominating. Another potential issue with this architecture is we are sort of coupling the bulk of the data with the computation need, right, on the broker, which means they can't be scaled out independently, right, which adds more operational concern and cost. And if you do need to scale them out, there's actually a lot of data you need to transfer, right, which adds further cost during the operation. So what we did at Confluent Cloud is to rethink about how to better use those cloud resources in our use case. What we observed is while a lot of our users care about this low latency real-time experience when accessing the most recent data, often when accessing the historical data, they only care about good throughput, but not necessarily low latency. So what we did in Confluent Cloud is to re-architect the storage layer to see how we can better utilize the storage in the cloud. In particular, we'll only be retaining the most recent part of data in this fast type local storage. But for the bulk of the historical data, we will be storing them in external block storage, which offers pretty good throughput, but at a much lower cost. With this architecture, as you can see, we significantly reduced the overall total storage cost. We also achieved the goal by decoupling the bulk of the data from the computation need on the broker, which means they can now truly be scaled out independently. And if you do need to scale out those brokers for computation reasons, now they can be done much faster than before because there's only a small portion of data that needs to be physically transferred. So this is one example how by rethinking about to use those cloud resources in Kafka, we can provide a much better managed service for Kafka. And there are a lot of such opportunities for further innovation in this space. Another recent innovation, which I'm really happy to talk about, is the innovation in Kafka's control plane. It's relatively rare in Kafka's history where we had innovation that significantly advanced the capabilities in multiple fronts. But today, we have such an opportunity. So when we started Kafka, we used Apache Zookeeper, which is a consensus service, to build our initial control plane. Zookeeper served us really well because it saved us a lot of effort to build out this initial distributed layer. It probably saved us at least 2 years of development effort early on. But as Kafka matures and evolves, this Zookeeper-based control plane starts to show some limitations in various dimensions. First of all, because Zookeeper is a separate system from Kafka you have to manage, right? That tend to make the deployment and the operational part a little bit harder for our users because they have to worry about the configuration, the monitoring, the securing of two separate systems. Over time, as people use Kafka more and more, a lot of people want to have those more topic partitions for better scalability. Even though we have improved the scalability of these topic partitions by a factor of 10 previously, but this Zookeeper-based control plane is showing some limits for us to make future improvements. Last but not least, sometimes when you try to reason about resiliency, right, when you have those corner case issues, it's kind of hard if you have to deal with two separate systems because you have to know where the issue is in which system, is it the usage of one system on the other. Because of those limitations in those dimensions, from 3 years ago, we started a journey to innovate the control plane in Kafka. So what we did is to replace Zookeeper with a new built-in consensus service we called KRaft. KRaft gets its name from the Raft consensus service. And if you're familiar with Raft, the core of KRaft is really just a replicated log. And at Kafka, we are really good at logs. So by bringing this Raft consensus algorithm inside Kafka, we can leverage a lot of infrastructure and optimization we had on the log in Kafka to make this much more performing. So with KRaft, we have made significant advancements in all those 3 dimensions. Because we no longer have the dependency on Zookeeper, we only have a single system to deal with, we significantly improved our story in terms of deployment and operation, and also the reasoning on resiliency. Because KRaft is optimized for Kafka's use on metadata, we can now increase the scalability of our metadata, those topic partitions, by another factor of 10, and we have the opportunity for future improvements as we go along. In the most recent Apache Kafka 3.3 release, I'm really happy to announce this KRaft feature is now production ready. And now I want to invite to the stage a longtime Kafka contributor, a Kafka committer, a PMC member, Ismael Juma, to talk about some of the details of KRaft. Ismael, please come on stage.
Thank you, Jun. Very happy to be here today to help share the KRaft story. I still remember when we started on this journey 3 years ago. It took more than 40 contributors and over 20 people years of people years of development to get to where we are today. It has been a massive effort by the Apache Kafka community. As Jun said, KRaft mode unlocks significant improvements in multiple dimensions when compared to ZK mode. So why is this the case? Let's compare both modes to understand this better. In ZK mode, we have Zookeeper as an external consensus and metadata layer, and one of the brokers also plays the role of the controller. There is only one controller at any point in time, and it is replaced if it becomes unavailable for any planned or unplanned event. The controller and Zookeeper share duties when it comes to managing and propagating the cluster metadata. This leads to a system with a number of edge cases and complexity. In KRaft mode, we replace Zookeeper and the controller with a KRaft-based controller quorum, which relies on a replicated log for persistence and metadata propagation. You could say that we bring all the benefits from Kafka that we all love into Kafka's own metadata layer. And now that you have a log, it's natural for us to have multiple controllers that continuously update themselves in the in-memory state for fast failover. This system is simpler, it's more resilient, and it scales better. It's worth noting that the quorum controllers can also be run on their own nodes. We call this isolated mode, and it's particularly helpful for large Kafka deployments. If you want to learn more about KRaft, Colin McCabe will be leading a session tomorrow, and I highly recommend you watch that. We said that KRaft scales a lot better. What do we mean by this? In order to answer this question, we ran a couple of benchmarks that time shut down operations. The first one, and more important one, times the recovery time after uncontrolled shutdown. This basically sets the recovery time objective of the system when there is an unplanned failure, like a node crashing or a data center becoming unavailable. In this benchmark, KRaft mode is 12 times faster than ZK mode. This makes it feasible to run Kafka clusters with millions of partitions. The second benchmark, we measured the controlled shutdown time. This is important for operational reasons. For example, you may be trying to do a rolling restart of the brokers, which allows you to roll new versions without impacting availability. In this case, the KRaft mode is 3 times faster. Both of these benchmarks are only some signals into the broader system performance of the system, but they particularly measure the known bottlenecks imposed by ZK mode. We said that KRaft mode is now production ready. What do we mean by this? Let's dive a little bit deeper. In one line, we're saying that the core functionality has been implemented for new clusters, and the system now meets the quality bar for production-ready software. Complete feature parity compared to ZK mode will be available in the subsequent release, including support for things like online upgrades from ZK mode to KRaft mode. Let's talk about quality. As Jun pointed out, the Apache Kafka community has done a lot of work to ensure the system meets our quality bar, and KRaft is no different. Let's talk a little bit about a few of the highlights. We run more than 20,000 unit tests before any change is merged. Every day, we additionally run over 200 hours of system tests. These tests are more complex tests involving multiple nodes and a number of failure scenarios. In order to complement these runtime tests, we also formally verify the KRaft protocol using TLA+. And last but not least, we ran multiple petabytes of data through Kafka clusters using KRaft. That said, for a complex distributed system like this, it's almost impossible to completely test every possible workload. So we ask you to also test KRaft with your own workloads and help us uncover any problems that may remain. Finally, we also fully integrated KRaft with Confluent Cloud. This helped us ensure that the system is operationally sound. We have the right metrics, we have the right logs, we can diagnose problems if they happen in production. Let's talk a little bit about the KRaft roadmap. As we said, Apache Kafka 3.3 was released yesterday, and it's a great milestone. But what's next? A quick disclaimer, this Apache Kafka is a community project, and as such, all these dates are subject to change. The next big release is Apache Kafka 3.5. This is what we call the bridge release. That is, if you're trying to migrate from a ZK mode cluster to a KRaft mode cluster, you first have to upgrade to 3.5 or newer. The other major highlight for 3.5 is that Zookeeper mode will be finally deprecated. This is basically a signal asking our users to start migrating their ZK workloads to KRaft. And one of the reasons for this is that 2 quarters later, we'll have the big 4.0. And in 4.0, ZK mode will be completely removed, and KRaft will be the new default. Beyond 4.0, we also have great ideas and, on how to make this even better. As Jun pointed out, we can scale the controller even further if we are to shard that controller. We're also looking at things like using KRaft for other internal topics, like the group coordinated topic, or even for external topics. Any big milestone like this deserves an awesome demo. And to make that happen, let's invite back onto the stage Danica and Kris Jenkins.
Back again, you can't get rid of us.
Absolutely. Thank you for having us back.
Man, all right, we're doing a demo.
We're doing a demo. We are doing a demo.
We have been taking a lot of selfies, so I didn't prepare anything to do.
Well, I have a little demo prepared, a little tiny little demo.
All right.
Yeah, I got a tiny
one.
demo
All right.
for you.
All right.
I'll show you something.
Okay.
Yeah.
Let's show them KRaft.
We need to get this sorted before we go any further. It's not KRaft, okay? Just for the record, officially, it's not KRaft, it's KRaft, okay?
Okay, I will give you that.
Thank you.
It's KRaft. Let's do it.
It's better, close, you're almost there. It's KRaft, darling.
Oh my gosh. Okay, KRaft. Let's do it.
No, it's KRaft. KRaft like it rhymes with graph.
Okay, Hermione, let's go. Let's get into
Never
it.
mind,
Come
never mind,
on.
never mind.
Let's.
Let's have a demo.
Where do we start? Okay, latest version of Apache Kafka. That would be helpful, right?
Latest version of Apache Kafka, released yesterday. It is 3.3.1.
Hot off the presses. Let's
Okay.
do it. Good enough. I bet not everyone here runs their own brokers. So what do we have to start with? Probably a properties file, right?
I've got a properties file. I've got one specially crafted for Craft. It's basically the same as usual.
Okay. There's a lot in there, but okay, for the folks in the back and at home, what is the difference between running Kafka in Zookeeper mode and running it in KRaft mode?
KRaft mode. So there's one new property. It's process.roles is running as a broker and a controller.
That's it.
You can do more fancy things in production, but that one change will get you going.
I'm going to need you to prove it. Forever, I believe you.
You believe me, of course you believe me.
Run it.
But shall we do Kafka server start? Oh, there we go. With my config KRaft server.properties, and I will run that in the background.
I'm not going to lie, that was a little anticlimactic. Okay, so, I'm so sorry. I know, we're here for the razzle-dazzle. So,
razzle-dazzle.
Again, proof. Why don't we run JPS and just show them that they don't see Kafka running and Zookeeper running.
It is now just Kafka. Ooh. As the Beatles once sang, all you need is Kafka.
It's true. All right, so we have Apache Kafka running in KRaft mode. Let's take it for a spin. Do you have any? Let's put some data in it, right?
I've got some data. I have some data that I think deserves to be put in an immutable log, recorded for all time.
All right, what do you got?
I thought we could do kcat and consume from a topic called contributors. And if we start at the end, that'll be a good place to start. Because do you know what? Getting KRaft into production has taken a lot of people and 3 years. And I think, it's time to give a note of recognition to all the contributors that made this happen.
All right, sounds good. Okay, so we have our consumer running at the end. Latest offset sounds good. Do you happen to have a producer up your sleeves?
Producer up my sleeve? I do have
Why
a
we
producer
wore the
script.
blazers, folks, okay?
I thought it would be appropriate to call this producer script Thank You.
All right. And really, he was not kidding. There are so many people involved in making this craft change happen. All of them are listed here. Thank you. Thank you to all of the contributors that put in the hard work over the years to make this happen. And it warrants a special thank you to the folks at Zookeeper for over a decade of collaboration. Truly, we would not be here without you. So thanks for the work.
Thank you. And here to give us one final thank you, please welcome back Mr. Jun Rao.
And thank you, Kris and Danica, for the great demo. And I want to also thank you for Zookeeper for all the services it has done for the Kafka community, but really look forward to what KRaft can do for us as a next generation of the control plane. Just to summarize, what we have seen is a new data streaming platform created by Kafka. I think with this platform, we are creating this opportunity for every developer in every company to take actions, right, on what's happening in the world. And we have seen so many use cases how this technology has helped transform various business. The core of success of Kafka lies in continued innovation. We'll continue the innovation in this space, and a lot of those innovation will be talked about in the sessions through the rest of the conference. So with that, thank you everyone for listening, and enjoy the rest of the conference.